Have you ever wondered what happens to the salt you add to your food or the sugar you added to your coffee? Well, let's find out in this video about dissociation in water. By the end of this video, you should be able to describe on a molecular level what an ionic compound does when you put it into water. You should also be able to tell me why compounds need to be in aqueous solutions in order for single and double replacement reactions to occur. Let's take a step back and review what an aqueous solution is. Remember that if a compound dissolves, we say that it is soluble. Typically, we dissolve most things in water, but not all compounds are soluble in water. Some may be soluble in alcohol, others in oil, and some may not be soluble at all. If a compound does not dissolve, we would call that compound insoluble. We form aqueous solutions when we dissolve a substance in water. Ionic compounds dissolved in water are said to dissociate into their ions. For example, when you put sodium chloride into water, the ions dissociate into sodium plus ions and chloride minus ions. Let's see how that happens.
Sodium chloride crystals are held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
The dissociation of ionic compounds in aqueous solutions is necessary for many reactions to occur, specifically single and double replacement reactions. Think about this for a second. If I had a strip of copper and a small vial of silver nitrate, and I put the copper into the silver nitrate, would you expect anything to happen? Probably not. But if I take that silver nitrate and add it to some water, the silver ions and the nitrate ions will dissociate. And notice here how the polyatomic part of the compound, the NO3-, stays together. That's because the bonds between the nitrogen and the oxygen are covalent bonds, and so it keeps the polyatomic ion together in the water. Once the silver ions are in solution, we're ready for the reaction with copper to begin. The copper ions replace the silver ions in the solution, leaving the silver to fall behind. Let's see what that looks like. Notice the silver forming on the copper wire. And notice how the solution is turning blue. That's the copper ions going into the water. If the silver ions had not dissociated in the water, they would not have been available to exchange places with the copper ions. This is what happens in a single replacement reaction and also in double replacement reactions. Coming up next, you'll be observing some single and double replacement reactions.